And then if you present, people should be able to see.
Okay.
The recording.
Okay, everyone. I think we are good. You're good. Okay. So, hello, everyone. Sorry for the delay. It's just small technical issues with Teams and recording. Welcome, everyone. It's good to see that there's a lot of people interested in this topic, and they all came here in this nice sunny weather here to a very hot room to watch scripting. My name is Francisco de Marques. I'm a geotechnical engineer, work at COE, and I will be the main presenter of this workshop, which is being organized by the BGA, the British Tunnel Society Early Careers. Okay, so you guys already know what is the structure. Let me just see if, okay, probably is recording. I hope so, is recording this. We only have these screens, so I think if I will try to find a way to be able to talk without blocking your view, guys. So, so this CPD is going to be structured in 4 sessions, okay? This first session today it's meant to be here in this room and also online, but the remaining 3 will be only online. And this first session, it's going to be more introduction about scripting and scripting in the context of Plaxis, and why do we do this? What are the advantages, and how can we use this to improve our process when compared with other methods that we usually use, like for example Excel or manual workflows. The remaining sessions are going to be more practical. Okay, they're going to be more in which we are going to work together. It's going to be online. I assume all of you have Plaxis installed in your machines, and I hope that you guys also receive a set of instructions how to install additional models that are going to be useful to have when we are running the next sections. So the second session is going to be more focused on input, and third and fourth sessions are going to be more focused on output, namely by extracting results and processing in the fourth session. Okay. So a bit of introduction about myself, just before we start. Like I said, I'm a geotechnical engineer. Currently, I'm working at COE. Okay. Throughout my 12 years of experience as a geotechnical engineer, I've been focused a lot of time in numerical analysis and specifically trying to do very complex analysis in which we have to do a lot of post-processing. And the whole idea I started to script was because at some point I realized that when you start to do very complex numerical modelings, especially 3D, and which requires a lot of 3D post-processing, you spend a lot of time. If you try to do things manually, you spend a lot of time trying to process the data yourself. You spend most of your time just treating data, cleaning data, rearrange data, which is good. It's good for, as an engineer to be able to have a feeling how the data is and be able to see where the numbers are coming from. But when we are in the project context, time is everything, and there's no project that, or there's no company that, or if you are doing a very time-sensitive project, last thing you want is to tell to your project manager that you need at least 2 weeks just to process data when they need the data from yesterday, let's say. So yeah, basically that's one of the reasons I start to script. Okay. I'm also just for your information. I mean, I'm also a Bentley qualified trainer. Before I from 2015 to 2017, I work in as a geotechnical support engineer in Plaxis. So that's where I was first introduced to these capabilities with Python. Okay, and at the moment I give some courses with the EJO expert. And just for information, I mean, one of the plans is to have a Plaxis 3D a Python course, more intense course coming up soon. No, there's no yet dates, but it's on the pipeline in the future. So I'll probably keep you guys posted once the course is going to be online. Okay. Just before starting this workshop, I think it's important to mention some important notes here. Okay. This workshop is meant to be just an introduction on the uses of Python to automate Plaxis input and output and to do the respective processing. Okay, it's not meant to be an intensive course. You will see in the next slides. I will try to describe a little bit what was my journey when I first started to script, and I think it's important to highlight that although this is a very powerful skill to have to script and to create these scripts, it requires a little bit of there's a learning curve, and sometimes you need to do some investment from your end to learn new coding skills, or try to run scripts from your own, try to learn from other people, search on the internet, try to find information. So I mean, we only have 4 sessions of 1 hour and a half. So we will try to do as more intense as possible, but there's always going to be something else that is not. We're not going to have time to cover. So I think the idea is just to be more an introduction. Okay. Like it was mentioned in the flyer of the course, it's recommended to follow this CPD course at least to have some basic knowledge of Python and Plaxis 3D. Okay, it doesn't necessarily mean that you need to have that, but if you really want to follow in detail the course without having any delays, it's recommended at least to have some basic knowledge of Python, which I think it was on the flyer. For those who don't have, I think, I'm not sure if is what are your levels of Python? Is anyone that is more new on Python or something like that? Okay, you can always search on Google, or there are free courses. There are some are paying. They are very cheap, but of course, with the time we have available, it's not possible to cover all these fundamentals of Python. But I hope that with this workshop, it kind of incentivates for those who are not expert on Python, at least, to feel more motivated to push a little bit the boundary to learn more. Okay. Like I said, the practical exercises are going to be in the next 3 sessions. Okay. And it's important. I mean, I will be carrying out the exercise using Plaxis 3D Advanced version 22. Okay. And having the geotechnical, I think before it was VIP license. Now it's called Geotechnical Select Entitlement license, which is the one that allows you to have the functionality of scripting. Okay, you need to have that one, otherwise you're not allowed to script with Python in Plaxis. The Python environment distribution that we're going to use is the one that comes with Plaxis 3D version 22. Okay. So in principle, if you install that in your machine, you have already that distribution. However, I would recommend you guys to install some additional libraries and models, which I think, Palak, I think you send those instructions, right? So I think everyone received these instructions, but I will try to spend some time, if possible, at the end of this session to show you guys how to install this. If anyone has any problems, I don't know if you guys try to install this in your machines or not, but I will try to see if I can find some time to show how to do that. Okay, and also just for notice, I mean, this section is the workshop sessions will be recorded. However, in this first section, we're going to talk about a little bit some case studies of scripting. And there's one particular case study that is more project related. I got permission to present in this course, but not the permission to be recorded and to share the material. So I would, at some point, I will need to stop the recording on there, and I hope you guys understand this. Okay. So my journey of scripting. I mean, I think I found this image on the internet. I think I find it very, very interesting because it kind of describes a little bit the difference between those that want to stick with the usual. They always stick with the same methodology, and they say, well, as long as it works, why change? Why change things if we always do the same things in the same way? Let's call the non-geeks. And the geeks are the people that want, let's say, to script, and they always want, let's say, push the boundary, or they easily get annoyed when they have to do a lot of repetitions. Okay, usually in civil engineer we have a tendency to, let's say, follow always the same recipe, because it's the recipe that everyone that does, and why change if it works? Which kind of works when your task size is very small, okay? But it reaches to a point that if you have to repeat a lot of repetition tasks, and a lot of repetitions, and the task gets higher, okay? I mean, you can see that the time span increased a lot, right? Now, most of the people, because the job needs to be done, and they don't want to get bothered to try to reinvent the wheel or to try to think about other ways. They just say, okay, well, we suck it up and we try to do this, okay? But for people that at some point they think that this is not the most efficient way to work, let's say they start to get annoyed at some point. So they think, okay, well, maybe it's better for me to spend some time to script. And of course, most of the people might have, probably you guys already have heard about people that script, and you ask yourself, well, why you're scripting something that probably takes like 10 minutes to do by hand, and you would probably take like 1 day or 2 just to script. Fine, because, I mean, fine, if the task is small, it's a fair point. But my point here, what I'm trying to, the point I'm trying to get here is that the time you spend to script, at some point, it might not compensate it if the task is small, but if the tasks start to increase in large size, and that's true, for example, when we are dealing with complex modeling like 3D models, or in which we have, for example, projects in which we have, I don't know, a pile foundation which has 100 piles, 200 piles, and you have to extract the results one by one. So it reached to a point that if you already spent some time to create that script to extract that, then in reality, it doesn't matter what is the size of the task, because you don't need to spend any more time. You can use all these the script, and you reach to a point that having the script, it becomes much more efficient than trying to do things manually. Okay, so I think this is basically kind of characterize my state, my let's say my opinion when it comes to automation is like, once you know how to automate, if you know how to automate tasks and you have ways to automate, you have already the scripts, and you face the decision to automate or to do manual tasks, I'll probably want to save the automation, because once you know how to automate, you don't want to go back to the usual way of doing things manually. Okay. So now that we identify a little bit in which situations we need to script, we already talked about that scripting only makes sense when you have a lot of repetition tasks, and there are a lot of them, that doing this by hand will be time consuming and would not be efficient at all. I mean, of course, we always have to start from somewhere, right? I mean, we all start from this starting point that we want to script, but we don't know where to start. So there's always like confusion, frustrations. We don't know where to start. So, and And basically, like I said, it's kind of a necessary evil, right, at first, right? Because I mean, no one, I mean, unless if you are very passionate and if you really love this, no one learns to script as a first choice. They will learn to script because there's something in the, along their workflow that kind of show the evidence that, okay, well, maybe if I script, I can maybe improve my work process. So it becomes like at first it becomes like it's some sort of necessary evil, okay? And the idea is that at the beginning, when I was creating my 3D models and do the processing by hand, I quickly start to realize that, well, you set up one time the model, fine, you do it. There's no problem to do things by hand. But if you have to run variations of the same model over again because someone asks, okay, well, can you change this? Can you increase the length here? Can you change those parameters? And for this small change, you have to spend, let's say, half a week or a week just to extract results and processing. At some point, you you get a little bit frustrated and tired, right? And also, but this is a bit. Oh, sorry, this is a bit my personal experience. Being a dyslexic in the industry environment, which we have a short delivery time and with high expectation of people delivering projects, it kind of pushed me to invest a little bit more on scripting. So how did I learn it? I learned by, first of all, a bit of self-learning and self-discipline. Like what I was trying to do is, okay, I want to learn, do some courses, dedicate some personal time to learn how to script. Talked with people that script, other people in the industry, or in the industry, or people from other industry. For example, data science nowadays is a very trending area, and there's a lot to learn if you want to learn to script. I really recommend you guys to see some courses of data science that focus on how to manipulate data for large data sets, and they have very interesting ways of manipulating data and cleaning the data and treat the data. Okay, you learn by that. Like I said, attending free and paid courses. I mean, there are plenty out there nowadays. I mean, Udemy, there's a lot of. I mean, these are paid, but for example, you can get courses intense of like basic Python courses, or courses that are more dedicated to certain models. I mean, some of them cost like $10, $20 or something like this. So it's not very expensive. Data Camp is more a subscription type of course. It's more focused on data science, but there's a lot of things in terms of data manipulation, especially with pandas, that can be very useful if you guys are into to know more. Okay. Like I said, data science and data engineering help. At some point when I try to do a little bit of the courses in the Data Camp, at some point I start to realize, okay, data science is more for statistics and more for machine learning, etc. But there's a lot of this area nowadays that we as civil engineers, because we have to deal with a lot of that. Sometimes I have been talking about numerical modeling, but there's a lot of examples. For example, it can be SI information. It can be monitoring data. Sometimes we get monitoring data and it's just countless rows of numbers of Excel spreadsheet that, okay, what's the meaning? How do I treat this? How do I make sense of it? So if you try to do it by hand, it's going to take ages. But if you have a script that can process that in a very efficient time manner, that's better, right? And of course, Googling help. Google is your friend in this case, and there's this website that is Stack Overflow, which it's amazing that sometimes you are trying to you want to do something, you don't know, and you search, and chances are that someone has already thought about that same question and they already find a solution to how to do it, YouTube videos, etc. So at the end of the day, I mean, we start here, but then once you start to get some, let's say, motion, there's a very big steep acceleration, because once you start to see the benefits, you start to see that there's a lot to learn until you reach a proficiency level, okay? But that takes time. This is not something that you take like a day or two. It might take a couple weeks, couple months. It depends on people. It depends how, if you already used scripting before or not, okay? So at the end, it's a bit of, there's a lot of trial and error here process, okay? So now that I talk about scripting, I mean, at least what was my journey in terms of starting to script. It's time for me to talk about a little about why Python language, why I use Python language in the first place. And it's important to notice that Python is not the only scripting language out there. It's just one of the many scripting language you have out there. And it really depends what is your final outcome, or what is your objective, okay? I mean, if you are doing, let's say, front end, if you want to do the web design, etc., there are other scripting language much better, like JavaScript or something like that. So the reason I use Python in the first place is, first of all, it's free and open source, okay, programming language, and that's an important aspect nowadays. We work in companies that we have to make sure that we use softwares that don't have any that they don't have any commercial issues to use for. Okay, so I can use my script for work and not be worried that someone is going to say, well, you're not allowed to use this software because you have to pay it. Okay, open source, it's very good in scripting, because it means that it's always getting improved by others. There's always people that are putting new stuff out there, and there are models like, for example, pandas, NumPy, etc. That they're so mainstream nowadays that you have already people that they spend, although it's a free model, but you have people that dedicated their time to maintain the code, which is good. It's a high-level programming level, okay? It's not like C++, which is very abstract, etc. So it's a simple to use, simple to understand. It resembles a little bit to human language and mathematical notions, okay? And most importantly, it's an object-oriented programming language, okay? So what this means with being object-oriented, okay? If we consider the object to be something that is a state plus behavior, okay? Okay, so let's say we have this example of a car. So in Python, I can describe things as an object. Everything is an object in Python, okay? If I want to derive, let's say, a script that deals, let's say, uses cars, so several types of cars, instead of me creating a set of code for each type of model, each type of brand, etc., I can create a class called car, which has a behavior, which is to be a car, okay? So it has methods. So what I can do with the car, I can define a method which is inside of that class and say, well, get fuel, get speed, drive. I can derive behaviors. So, and the attributes are kind of the variables. So, for example, the fuel is going to be the one that it's going to be the variable that feeds to this function to get fuel, something like that. So it works as some sort as a blueprint for objects. Okay. And the good thing is, once you define these objects, you can always reuse this for other code. So it's not, you create for once, and if you need to reuse this in the future, you can always reuse this later. So it's like some sort of building block, okay? And also another big advantage is it's an interpret language, and that's one of the biggest advantages when compared against the compiled language like C, C++. What that does mean exactly to be interpret language. Let's have a look, for example, here on this first one here, okay? So let's say we have a C or C++ language. The way it works is you write your code, you have to compile into something that is in the machine code language, so the machine can understand what needs to be done and run the program, okay? But if there's any problem, so it's like you compile this into a program and then the machine runs the code at once, okay? Everything at once. If there's anything wrong in the codes, the only thing you will get is just error. You don't know what is happening. You don't know where's the error. It's more difficult to debug. Being interpreted language, it means that you write, for example, in Python, you write your code, and the program, there's an interpreter that is going to run the code line by line. And if there's a problem in your code, on that specific line, it will stop here, and you know exactly where the error is. So in a way, it's much more user-friendly and helps people to understand what the program is doing. Of course, not everything is just advantage, of course, because as you can imagine, if you have a compiled language that you can translate everything into a machine code and then run the program, it's going to be faster. So if everything goes well, to run that program is going to be much faster than have a language that you have to run every line one at a time, okay? So that's one of the main disadvantages of Python now. So it's an advantage and disadvantage, but it really depends what your end goal here. For us, civil engineer, because we don't deal like with big data sets, like for example in data science they do, it's not a big thing. But for example, in areas that they have to deal like with let's say Excel files with, I don't know, 1 million rows, that can be a problem, okay? Just continue here with the free and open source aspects. Here's just an example of it's not the only ones, or there are much more, but I just put here the ones that, in my opinion, is for the civil engineer contest, is the ones that most likely most of you guys are going to use, okay? First of all, we have NumPy, which allows us to do linear algebra and allows us to build matrix in Python, okay? It's a little bit similar if you guys are familiar with MATLAB, okay? It kind of follows the same methodology as MATLAB, okay? So I like to think that NumPy is like the MATLAB version of Python, okay? SciPy, which is a scientific library. So if you want to do interpolations, if you want to do second, third, or fourth derivatives of a function, this is the library you should have. Okay, this library contains the function to do that. Okay, pandas. I think it's. I'm not exaggerating when I say this, but consider pandas like some sort of Excel on steroids, because it is that, because one of the main limitations we have in Excel, and probably most of you guys have already faced that problem in Excel, that there's such limitation on Excel that you can only have certain number. I don't remember how many rows you can have, but if you pass a certain number of rows, or if you start to have very large Excel files with a lot of information, you start to see your program lagging and it becomes difficult to work. Pandas, the big advantage of pandas is that you can deal with such large Excel files and be able to process the data in a very quick way, and also it's very useful. Let's assume that pandas is the equivalent of Excel in Python, okay? And then, of course, we have matplotlib, okay? Matplotlib is a very known library to graph and chart creation. So if you want to create plots and etc., definitely you need to have this one. And also you have Seaborn, which Seaborn is constructed based on Matplotlib, but I put here Seaborn because Seaborn allows you to have access to certain fixtures on Matplotlib that Otherwise, in Matplotlib, if you want to do some actions to create plots, it required, let's say, I don't know, 4 or 5 lines of code. With Seaborn, you can do this in just 1 line, for example, or you have better formatting options. So it's always good if you want to have more plots that are more well formatted than Matplotlib. Definitely, I would recommend you guys to explore this library, but otherwise Matplotlib should be okay. And finally, Streamlit. Although it's not fundamental, but I think once you start to create scripting, and if you are using scripting for yourselves, okay, fine. You don't care about if the code is tidy, if the code is well formatted, if it is user friendly, if it is easy, if you share the script to someone, that person, even if it is someone that doesn't know Python, or even if it is someone that knows Python, they're going to understand the script or not. The whole idea of Streamlit is to be able to create front-end web apps. Okay, so imagine the script to be your backend, and then Streamlit kind of creates some sort of graphical user interface that is 100% written in Python, and you can, let's say, if you want to share your script with people that are not coders or they don't know anything about scripting, you can create apps that say, well, you just click this button, import this, adjust the slice, and in principle, anyone can do it. I will show later some examples of this. Okay. So now let's move on to the Python and Plaxis. Okay. The way we use connect. We use Python in Plaxis is by using an API it comes with the software. Okay. In the software is called remote scripting server. Okay. And this API kind of works as a kind of bridge between your Plaxis program, okay, and your Python language. Okay. So having this API, then you can allows the user to control both Plaxis input and output based on the scripting. Okay, so as you can imagine, if you are allowed to control your Plaxis installation, your Plaxis program using scripting, and you can automate tasks instead of you going to the program, you all probably familiarized with Plaxis workflow that you have. If you want to create something, you have to go to the soil mode, create the soil, create the structures, and then move to mesh, then create the construction stage, and you have to do that manually. But if you have a script that you just set a set of logic instructions, and the program can do that for you, not only that on input, but also on the output, I mean, the possibilities are almost endless if you think about it, because once you can do this, I mean, it's up to your imagination and up to your goals, or it's up to you guys to decide where you want to draw the line. Okay. So just to highlight again the advantages and disadvantages of scripting here. Okay, but more now on the focus on Plaxis. Okay. I like this example of drilling a nail in a wall. Okay. Let's assume that you guys want to put some paintings in a wall, right? At your home, and you only have 1 or 2 paintings to do. I mean, if it is just 1 or 2 paintings and they're not very heavy, they're very easy, a simple nail can do it, then an hammer is enough. You don't need to have like a heavy-duty equipment to drill on the wall just to put a simple painting, right? And that's basically what happens when we are doing manual workflow in Plaxis. So here you can see the screenshot of a Plaxis, right? Just a moment. I mean, I guess you guys are all familiarized with this, that if you want to do something in Plaxis manually without any scripting, you just go there, and if you want to draw a line, you just click here, create a line, and that's it. I mean, anyone can do it. The learning curve is low, so You don't need any scripting for that, of course, or you don't need to understand the commands in Plaxis to do that, because everything is graphical interface. But of course, there are disadvantages, because if you have to repeat this several times, let's say if you have to do one line, fine. But let's assume that you have a 3D model, and you are asked, and you are supposed to create, let's say, 100 piles with different lengths, in different locations, in different with different lengths, different pile platform levels, different toe levels. If you are going to try to do this manually, not only is going to take a lot of time, but also there's another important aspect, that such repetitive tasks, at some point you become so tired that you're going to be prone to mistakes. Okay, you're going to do typos, you're going to, at some point you have to go back because you'll figure out, oh, I did something wrong. So that's when you start, when you start facing these kind of things, you start to realize, okay, well, maybe it's time for me to find a more efficient way to do this, okay? So what is the next step, the next level of this? Even before we move on to scripting, okay? Is the use of command lines. And I think, also, again, this is something that I think most people that, at least people that probably work with Plaxis 3D, they probably already take advantage of the command line, because if you know what is the, if you know to define, let's say, a line in command line, which it's very easy, right? It's just, if you want to create a line in Plaxis, you just put line, you put the coordinates of the first point and the coordinates of the second point. That's it. Then if you put everything on Excel, then you just create, let's say, the base of the line, and then let's say you put, let's say, on the first cell line, and then on the second column, the third column, let's say you put the coordinates, and then you drag down whatever, because if you have, like, say, a set of coordinates that is already represented somewhere in Excel, and then you just copy paste some to Plaxis, you should be able to represent these 100 piles very easily. Fine, but there's just a problem that it's a semi-automated process, but you don't have any runtime decisions. Let's say that at some point you want to create something that, let's say, for example, in this case here, let's say a point load that I have, like, let's say it's a certain set of coordinates, everything is fine, but the naming is the same. Let's say this one calls point underscore 2, and this is underscore 2. Because in Plaxis we cannot have objects with the same name, when I try to run this command, it will tell, well, it's already there, so there's nothing I can do, and stops there. And you probably already realize that, or most of you guys have already noticed that, if you try to, let's say, to go to the command runner in Plaxis and try to, you create a set of commands in Excel and copy paste it, and you, let's say, I don't know, 100 commands, but then only to realize that the fifth command, something went wrong and stop there, because the program doesn't know what to do. There's no logical decisions. There's nothing that tells to the program, okay, if you bump with this problem, do something else, okay? So that's when you have to move on to the next step. And also, the other aspect that is important is that with the command lines, you cannot script outside of the project context. You can only run these commands in Plaxis. But if you want, let's say, well, let's say I was in output and I want to extract something, then with this workflow, I cannot automate the process in Excel. Say, well, copy paste this to Excel and plot this, something like that. So you cannot do that. Okay, you still rely on manual activities. And also, if you want to save the results, let's say, into, let's say, a text file, CSV, Excel file, you cannot do with the command lines. That's when you need to go to the heavy-duty equipment. Okay, so again, this drill is like, okay, you have a lot of things, but you're still very limited on what type of activities, like for heavy-duty activities. Only when, let's say, if you have something that, okay, I want to extract a lot of results, and I want these results to be plotted, I want these results to be saved in Excel, so it's ready to be plotted in a report. and I want to do this in a way that I don't have to do these things manually. That's when you start to do scripting, okay? Because then you can go beyond the native Plaxis capabilities, because you can connect Plaxis to automation outside of the project context, connect to other third-party projects, softwares, etc. The repetitive workflow, the repetitive manual work is no longer exists. But as you can imagine, and you will see, I mean, this is an example here. Just see if I can just put this to run here. Sure. Can you all see? Yeah. So this is an example of Streamlit. This is a Streamlit app in which basically you just set up, you initialize the remote scripting server, connects to Plaxis. Then I select, okay, which file I want to select to extract the results. Then, okay, he knows the file is located here, okay. And then here we put, say, which phases we want to extract. Phase 3, phase 4, etc. And why this is important? Because in Plaxis, if you want to extract results, you have to go one by one. You cannot extract results like, say, well, extract all the results and save in Excel. No, if you want to extract results manually in Plaxis for piles, let's say embedded beams, you have to go to one embedded beam at a time. So, but if you really need to extract results for all the piles, then, and you want to plot this, and you want to plot not only the results on one phase, but for different phases and comparing the plots, you already can imagine how much time you're going to spend to do that manually. Maybe for one pile, it's okay, but if you have to do this for multiple piles, and you have to rerun model countless time, and do that again all over again, I would say that not only is not efficient, but you also at some point you probably want to give up to trying to do this, okay, but manually. Yeah, so basically these are the. But as you can imagine, this is the advantage, of course. But not everything is. There's always disadvantages, of course, because it requires a little bit investment. You don't script. I mean, you're not. These kind of things you don't create this like in just a couple of minutes. You require a little bit of time to spend, but once you create it, and if you can find ways to utilize this in different projects, in different work, then you will see that once you create for one time, you don't need to, you can reuse the code for different projects, and I will show you later some examples of that. And of course, it's not worth it for simple and straightforward projects. Like I said, I mean, if you have like 2 or 3 piles, I mean, it's like you're not going to drive a Ferrari in the countryside, right? So, okay. In terms of connection, okay, how do we connect Python with Plaxis? Okay, to connect, like I said, we have to go to the remote scripting server, okay, on Plaxis. We just have to make sure that we set up a certain password here. It can be any password you want, okay. And then this is how we initialize it on the Plaxis side, but on the code, we need to have this boilerplate Python code here, okay, which basically it will allows us the script to talk with Python, the script to talk with Plaxis, okay. And as you can see, there's going to be like variables, objects that one is a server and global. Server is an object represented in Plaxis input output, the program itself, and the global is where you can call. If I have to simplify this easily, is like an object that is bound to the global objects of the current Plaxis model that is open. So, for example, if you want to open any project, let's say if you want to automate opening and close projects, then use the server object. But if you want to tell the program to create lines, to mesh, to delete stuff, then you have to use the global one, okay? And you can see this line is for the input and this line is for the output, okay? So this is a mandatory piece of code that you always need to put in your scripts, okay? In order to make sure that your script is talking with Plaxis. and also making sure that this server is initialized on Plaxis. Now, okay, so the good thing about Plaxis, I mean, one of the things I think it was a clever way of starting this from Plaxis size and Bentley size is in order to make sure that it's easy, people can use Python and Plaxis very easily and without trying to reinvent too much the wheel here. You'll see that a lot of the commands in Plaxis, they already follow a little bit the philosophy of object-oriented programming, okay? So what that means is that if you know how to create the certain things in Plaxis, let's say if you want to, you have a point that is called point_1 and you want to rename that. How do you do that in Plaxis? You put the command, which is rename, okay, that's mandatory. You say what is the target object, which is the point_1, and then you put the parameter. In this case, I want to rename this from point_1 to test point, okay? And that's what we do. If we do this, we can do this, that. If I want to replicate this in Python, it's not going to be 100% equal, but you will see there are some similarities, okay? Instead of the command line, command names being the first one to put, you put the target object, so it's going to be the G. G is the global. It's the object, and then you have to access the attribute of the point_1, which is the point. Okay, so that's your target. You say, oh, I want to target this point. Then you put dot again, and then you put the command line rename, and then you put the parameter. Okay, and as you can see, this command here is quite similar to this one here also in Python. So you can also, there are several ways. There's no unique way, but usually, I mean, either this way and this way works, okay? But as you can see that if you know the syntax of the command line in Plaxis, then if you want to script something and you don't know how to do it, you can easily get there. You are already halfway through of the process, because if you know already what's the syntax, then it should be by a bits of trial and error you can get there. Also, keep in mind that I can show you guys later that in Plaxis there's help menu. There's a command reference, okay, a command reference both for the commands and both for scripting. So if you always want to know how to do something, you can always refer to that piece of documentation in Plaxis. Okay. Okay, so let's move on to case studies. The first case study is going to be a single pile calibration. Okay, so we are going to try to calibrate a low displacement curve. Okay, so let's assume that we have a pile that is 15 meters depth in London clay. These are the properties of the stiffness of London clay. So it's going to be this 24 plus 2.4 Z, and it's multiplied by a multiplier. Okay, this is a multiplier here. Okay. Z is the depth from the top of the London clay. Very typical ground conditions here in London, and it's going to be 1200 rotary dry pile, 50 meter length RFA, platform level at 60 plus MOD, and of course, if we want to calibrate, if the goal is if we have a pile and we have a pile test, or we have a Fleming curve, or whatever, something that we can get some indication what will be the true behavior of the pile, and we want to make sure that our model is reproduce that behavior. The better way is to calibrate our solve parameters to make sure that we can derive a set of parameters that can replicate the pile behavior numerically against any tests or any empirical method. For the pile for this case, I mean, because it's single piles, it's going to be a circle, so we can use a 2D axis symmetrical model. So only half of the pile is model, and of course, in this case, it's going to be a volume cluster. Let's call more a cluster element with interfaces associated. Okay. So if I wanted to calibrate this pile. If I'm in the project that, okay, somehow I have to get some validation that my salt parameters are accurate, and the only way that I have to prove that is by doing a calibration and try to see if I can match the numerical response with the real pile, with the pile test curve, let's say. How can I do that manually, let's say? Manually, so I will first plot the load displacement point from in situ pile test, okay? The next step will be, okay, I will set up my model. I'll put a best engineered judgment prediction of the sub parameters based on SI, based on past experience, etc. Then I will run the calculation, the calculation with this set of parameters, right? Then once I run the calculation, I extract the results, plot it in output, try to plot the load displacement curve in Plaxis, copy paste this to Excel, so I can overlay with my pal test and see where I am, if I'm getting a good match or not. If I'm not getting a good match, if I get a good match, then fine, happy days. If I can get this, if I can get a Class A prediction, even better. But if not, then I would need to review, modify the parameters, maybe change slightly the parameters, and rerun all this cycle again until I get a match. Okay. The ideal scenario, like I said, is a Class A prediction. So everyone wants to be in a situation that we can at first try, we can predict the cell parameters in one go, and we just run one analysis and we get the perfect match. But also we want to make sure that the time and human our time is not going to be waste, and also make sure that there's no mistakes along the way by doing repetitions, right? But the most realistic scenario is that, I mean, most certainly your calibration might require a couple of iterations. It might require, I don't know, 2 or 3 iterations, but it will require some iterations. Okay, so how long is it going to take? It depends. I mean, if it is like it can be a couple of minutes, hours, days. How can we prevent the typing and repetitions to happen? I mean, because once we have to run the model context time, we have to go to the model change, and then it's very easy. Probably you guys already noticed that in Plaxis, it's very easy sometimes to do some typos, or for example, you're putting in stiffness and you forget that you're putting things in kilopascal and you put the stiffness in megapascal. That's a very common mistake that people do, because sometimes you're doing things automatically that you don't stop to think about. So yeah, I mean that will be the most realistic scenario. Of course, if it is a very simple exercise that only require 1 or 2 calibrations, fine. But and let me just move here to a live demo. So let's move here to Plaxis. Okay, so let's go. I'm not going to run the model, let's say, but I'm just going to open a model that is already, let's say. So the idea is, let's see how, for example, let's try to see how the first. Sorry. So let's try to do this manual case in which we have, let's say, a multiplier equal to 1, the R interface of the pile is 0.55, and the K naught is 1, okay? And there's only one set of parameters. So the way to do this will be, can I move here? Yeah. So the way I will do this is just I will go here to Plaxis. Can I? Yeah, you have to move like this. So I open the output. Let's say I run the model, I open the output. Then if I want to extract, then I would need to go. Where's the mouse? Okay. So like this. So I'll need on the Plaxis model, I'll need, for example, to say, well, okay, I want these nodes, I want to record the nodes, the displacement, the displacement at this point. Then I will just need to open. No. Yeah, Chris. Sorry, it's not easy to see things like this. That's better. Okay, so if I want to start the results, because it's here. Sorry guys, it's just this is popping in different windows. Okay, so now I have to move here. Okay, so if I want, then I'll need to extract the results. So because we have a pre-select value here, and I'll now appear again here. Okay, so what I need is, okay, I need something that is plot in terms of load displacement. Okay, so on this one, I want the force because it's an axisymmetrical model. I can have the reaction of the reaction of the analysis. This reaction is going to be it will correspond, and also because in this axisymmetrical model, I'm putting impose displacements. So what I get a reaction, right? So I can plot this in force, and then here I can go here and say, let's say deformations and total displacements here. Okay, fine. So you see that we have here the curve. Okay, we have the curve. So then, I mean, then the next step will go here and say, okay, well, it's here. I'll need to copy paste all these results, and by the way, this is in kilonewton radians. So in order to be able to represent the value, I'll need to multiply this by 2 pi. Okay, and also convert this in meters to millimeters. So then, what I will do now is I'm just going to open the Excel just to the Excel of this. Just wait a second. BGA. Presentation. Processing. Okay. Okay. So then what will happen is, like, in this scenario, I will just copy paste that information that was on the table into the Excel. Here okay, these are the results from Plaxis. Then I still have to convert these kilonewton radians to kilonewtons, convert this to millimeters, and then I have here the PAL tests data. Okay, so then just so you see that, I mean, that's how you do this manually. Okay, if you were to do this manually, this is basically that word flow chart I showed. This is basically what you do. Okay, so you can see that this is the Plaxis numerical curve. This is the PAL test, and you can see that they're still not a match. So that means that I need to rerun again my analysis. Okay, fine. Go to analysis, change the parameters, do all over again. We can do that, or we can push the boundary. We can push the boundaries and script. So if I go now back here to the presentation, okay, go back to the script. And Sorry guys, I think I'm having some, for some reason, I don't know why it's happening here. Ah, there it is. Okay, so we are see that it's an iterative process. Okay, so it's a bit of trial and error process. We already talked about that. It can be time consuming. Of course, if you have to do this multiple times, the chances of errors are big. So how can we do this in a more clever and efficient way? By scripting. So we still repeat the same tasks that we plot the load displacement curve from the PAL test. We apply a first set of parameters based on our engineering judgments on Plaxis, okay? And let's say we have a simple model, like a model in which, let's say, a base reference model in which we set up the geometry and then Plaxis input, we run it, then we tell to the program to go to the output and extract the load displacement curve automatically. Same thing. Then it will plot that into a plot in a script. Saves the calculation load in the the load displacement curves in a text file. And then we can make the call, right? I mean, we can put multiple parameters and test. We can say, well, we want to test, I don't know, 10, 20, 30 set different parameters. And then at the end of these runs, if we still don't have any match, then we just repeat the test all over again. And then if it is yes, then it will save the final plot as a PDF and it will finish the script. Okay, that's the efficient way. And the parameters that we are meant to change in this procedure is the multiplier, the R interface, and the cannot. Okay, so if we have a script that can do this, you can see that now, for example, in this case, we have 18 possible combination sets for all these parameters that we asked to test. And all of this with the script, it only took 20 minutes to do it. If you were to do this by hand, probably you will reach at the 10 model, you probably say, well, it's enough. Maybe I don't want to do anymore. So let's now do a live demo with the automation, okay? Just, okay, it's in the model, yeah. Script. Okay, so now what I will do is I will open the script. Okay, I'll go here to Jupyter Notebook. Now I just have to tell the program where I want to open this script. Okay, it's going to be here. Okay, so now I have here the script open. Okay, so this is the script. Let's see if I can just put this in a way. Sorry, I'm just moving here. Just otherwise it's difficult to see from here. Okay. Okay. Right. Let's see if I just can this in a way that. Let's put the script here and let's put the program here. Okay. So this is an example of the script, guys. So as you can see, I mean, part of the process. I mean, it starts from here. The part of the iteration process starts here, and then the part that plots here, it has different cells here. So as you can see, if I have a script here, and then I now just run it all, put run. So now we just have to wait. It's just going to run two set of parameters just to be quick. Just wait. Okay. And you see that it plots here at the beginning. Whoops. At the beginning, it plots here. It's already run things on the background with the first set of parameters. So it's testing multiplier 1. I call the R interface alpha 0.5. It cannot 1. Okay. So it will do this, run the analysis on the background, and once it runs in extract, it will plot here automatically. So we can have in real time. In real time, we can see how our calibration is doing, and if by any chance if we are running a large set of parameters, let's say 30, 30 different combinations, then if we already figure out, okay, well, actually we already found something that match, we can always stop and analyze to see if that satisfies our criteria or not. So let's see. So it should, at some point, it should appear the curve. Yeah, you see. Actually, this one is already a good match. So let's say if after running a couple of analyses, if I see already something close to this, I would say, well, maybe this is already good enough. But if it was too off, I will just leave the script running this until I get something that I like or I'm satisfied with. So let me just now, in the meantime, while he's running the other one, let me just go back to the presentation, okay? Okay. So again, you guys probably noticed that there's still a little bit of manual process here, a process that I still have to make the decision myself. The script is not telling me, okay, this is the best set of parameters. What the script is doing is I say, okay, I want you to run 20 different set of parameters. It runs, but it doesn't know how to stop when you have to say, well, if you reach already a good set of parameters, just abort here and you don't need to do anything. So, yeah. So, I mean, this is just an example. I mean, something that I try to replicate. This is based on work being made by Anna Pirone, on her master thesis that she won. I think she won the best master thesis last year on the BGA, and she tried to implement some optimization techniques and machine learning in geotechnics, okay, using scriptings. And that gave me the inspiration to try to, after reading her work, that gave me some idea that, okay, maybe we can apply something like, for example, this, like it's a particle swarm optimization, which basically try to replicate mimic the behavior of swarm of birds and fish, which, as you know, birds, they move in group, and they tend, the way the birds oriented is that they are trying to find something, a place to rest, a food, etc. So each one of them trying to find, they don't know where it is, they're trying to find, but they try to follow the group. So this is kind of trying to replicate this kind of behavior. As you can, if you imagine these particles to be any different, let's say a different solution, different type of, each particle is one analysis with different parameters. So this is a 1D, a one-dimension particle size optimization. So we only run the analysis by changing the R interface, and we are running until we make sure that we minimize the error by using the less square method, okay, and making sure that by the end of couple iterations, both particles, they are converging to the PAL test. That's going to be the future, and I think this is something that is still, like in other areas, is already well implemented, but we are still a bit years away of implementing this in civil engineer. But I think if we never try, we'll never be able to do that. So I think my next steps, if I wanted to implement this, well, and this was a little bit like a pet project that I did just out of curiosity, and I found it very interesting. So try to implement this to multidimensional machine learning. So you can see that nowadays we have now the ChatGPT. So you can see that our success as an industry, relies a lot of us how to know how to implement these tools to our advantage, to our works. So another case study is a rock bolt result extraction for a deep mine. This is a work from COE, okay? The only thing I can say is a deep mine located at 1 kilometer depth, okay? The mine diameter is 26 meters. And as you can see, there's a total number of rock bolts of 293 rock bolts. And the challenge here was, okay, we create this fancy 3D model, but okay, well, now we have to extract the rock bolt results in the post-process that. Okay, you do it once, but then if you have to do this, if you have to rerun model several times because you want to do a sensitivity analysis on the parameters, yeah, you can see that, I mean, the time required to do a manual extraction and processing the results manually, and this is a general feeling I got, is it would take up to half a week to 1 week of engineering work to do that, which basically is, if you think about, it's time that you're spending doing things that, instead of you spending time doing things like judging the results or doing some engineering thinking, no, it's just spending your time doing repetitive work like if you were a machine. Well, so what we did in here was to create, to use a script written in Jupyter Notebook, which basically extract the results on Plaxis 3D, and then it will generate, let's say, a PDF ready to be input on a report or anywhere you want it to, for all matter, which basically is going to be this one here. Okay, so as you can see here, let me see if I can just show. So here you can see there's this is just one page for one. It's going to be, in total, it's going to be 292 pages. Each page is for each rock bolt, in which we are indicated with location of the rock bolt, and then we are saying, yeah, okay, what are the actual forces, what are the actual skin resistance, and then another thing that was important to plot was the rock bolt displacement, the displacement of the rock, and try to determine the relative displacement. Now, the relative displacement is not something that you can get from Plaxis. You require some processing to do. So if you have a script that can do this automatically, and then also plot, let's say, if you want to get an envelope, you just plot everything on the same plot and try to say, okay, what are the envelope, or what is the lower and upper bound of movements in terms of actual forces, actual skin resistance, vertical displacements. I mean, all of this took like 30 minutes to do. Of course, it takes some time to set up, but the good thing about this one is that actually, when I start on work on this, I didn't have to start from scratch because I had already scripts that could extract results on piles. The only thing I had to do was just adopt this to rock bolts, and only took like a couple hours to do that. So as you can see, once you create a script, even if you don't use 100% of the code in next projects, chances are that you're going to use like 80%, 90% of the code. You just have to adjust the other 5, 10% of the code. Okay. Another example is, I think, I'll leave here also the link if you guys are interested to have a look. This is an app that I developed. This is based on GMA's works, and I mean, if you guys work with GMA's impact assessments, you guys know that sometimes you have to extract results from softwares like XDisp to do impact assessments and make sure that the strains are okay, etc. But the problem with XDisp sometimes is, for example, on corner, if you are trying to extract movements behind the wall or utilities behind the wall, especially for especially for longitudinal movements. So don't mind about the names here; they're swapped, but these are longitudinal movements. Sometimes it gets these spikes, for example, and you have to smooth it. So it's quite normal for us to do a little bit of curve fitting, smoothing, etc. So yeah, you can do this in Excel, but it's not the most efficient way, or you don't always get the results you want. You can do scripting, but then at some point I realized that I was the only one that knew how to use the script, and if I want to give this to someone that was less experienced on code, they didn't know how to use the script. So I came up with this one that basically what allowed me to do is, so if I go back here, okay, let's see if I can just go here, just okay. So if I open this, so it's a web app, okay, so the good thing, that's one of the advantages of Streamlit, is that you don't need to have Python installed in your machines. It's everything run in the cloud. A nice user interface. You can set up whatever you want. Then here I will just say, okay, I want to extract a set of movements. Okay. Now let's just have to put a name here. Let's say test. Okay. Now, as you can see, it will have these sliders here. Then I can start to play around with the sliders. You know, instead of, because the other way would be like, if I have the script, I have to go to the code and change the parameters. So every time I want to change, or if I want to refine a little bit the smoothie parameters, but having an app like this, for example, can help me to do that. So, and I can also change, let's say, the algorithm I want to use. So let's say I can use either a cubic spline smoothing and one-dimension spline from a SciPy package. So yeah, I mean, so you can see that if I change the slider here, instead of me going every time to the code to change the parameter, I can go here and make that smoothing much more straightforward. And the good thing is, if you know how to do this in Python, and if you want to have a more clever script in that, let's say you're doing impact assessments, and you extract the results, but you want to remove the manual part of smoothing yourselves, if you know how to do that, you can incorporate that part of the code to the extraction of the results and have, let's say, a script that can do all as possible. Okay, right. So this is the part of the course. I just have to stop the recording, like because of the reasons I explained before. So let me just.